This is a video that's going to cover the distance formula. Basically, it's going to help us find the distance between 2 points. We did see one way to do that in the previous section with the Pythagorean theorem, and the reason that we do the Pythagorean theorem first is because it's very closely related to the distance formula. In fact, the distance formula comes from the Pythagorean theorem. So just as a quick review, if your 2 points were on a coordinate grid or you graphed 2 points, you can always form a right triangle with the 2 points, get your 2 legs, because this is a right angle, so this would be A and B, and you could solve for the distance C, which is our hypotenuse. So you can always do that, but like I said, we also have something called the distance formula, which will help us when we don't have something that's graphed. So this is the distance formula. Looks like a giant mess when you first look at it, so that's usually what I end up getting anyway, or hearing. So we're going to get rid of this here. And how does this work? Well, basically, a couple things that you can see. It looks, or it seems to have parts anyway, of the slope formula. Remember the y2 minus y1 over the x2 minus x1. So basically we're going to subtract our x values, we're going to subtract our y values, and it doesn't matter which point we choose first as long as we go in the same order both times for the subtraction. So I'll show you what this looks like. Basically, I will take the second point, so remember it doesn't matter, but I'm going to call this my x2, y2. X values are always first. And we'll call this our x1, y1. So in my formula then, I'm going to take 6 minus 2. Oops, those are my y's, sorry. So 6 minus 2 would go there. My x's are going to have to then be 1 minus negative 5. And that would be squared. So now, basically, we're going to simplify within the square root. So first off, I'm going to do 1 plus 5, because we're minusing a negative. So that's 6 to the second power, plus 6 minus 2 is 4 to the second power. And all of this is underneath a square root. And then we just keep simplifying. So 6 to the second is 36, and 4 to the second is 16. And then 36 plus 16 is 52. So the square root of 52, it's an irrational number. If we put it into a calculator, we would get a crazy decimal. But it would be the approximate distance of the approximate length between, or distance between, these two points that we were looking at. So we could say the distance between the 2 points is radical 52 units. However, oftentimes they'll ask you to then simplify the radical if you get one. Or they may ask you to round it to the nearest tenth or something like that if you get the decimal. Anyway, 4 and 13 both go into 52. I always remember this one because there are 52 cards in a deck, 4 suits, 13 cards per suit. But anyway, we know the square root of 4 is 2, so we could also say that this simplified radical is 2 square root of 13, and that would be the distance. Again, you could also use the Pythagorean theorem for that to figure out the distance, but you'll see on the next slide why you might want to stick with the distance formula. And the reason being, because if they don't graph the points for you, you would have to graph the points and then form the right triangle. And you can always do that, but it does take a little extra time. So sometimes using the distance formula might just be faster. So again, it doesn't matter which one we choose to be first or second. So I'm going to switch it up, and I'm going to say x2, y2, and x1, y1. And if you wanted to, you could try it the other way, and we should come out to the same answer. But basically, I will be doing negative 1 minus 4 to the second, plus 5 minus 1 to the second power. And here's where it gets a little interesting. Negative 1 minus 4 is negative 5. And 5 minus 1 is 4. And the reason I said here's where it gets a little interesting is because we can see we have a negative inside the square root, which is not possible. But the good thing about the distance formula is when it's not possible to have a negative for an answer inside of a square root, but the distance formula will always spit out positive numbers no matter what. Because remember, a negative to the second power means negative times a negative. So that's negative 5 to the second means negative 5 times negative 5, which is 25. So, like I said, you cannot have a negative answer inside a square root. That's an imaginary number, but remember here we're not done simplifying yet, and the distance formula will always spit out positive numbers no matter what. So anyway, this will then be 25 plus 16, and if I add those two things together, we will get 41, and we can't simplify that any further. So we could say that the distance between those 2 points is the square root of 41, or if we wanted to, we could type in 41 into the calculator, which I'll do real quick here. Square root that, it's about 6.4 units. Okay, so depends on what answer they're looking for. They will let you know which one to give. Pretty much everyone that we look at, or at least for the most part, will be looking for that simplified radical. And square root of 41 will not break down any further. So that is how we use the distance formula.